Hi, this is a little helpful video on vectors and matrices to prepare for the semester final. Okay, so let's take a look what we have here. An auto dealer has two locations, one on the east side, one on the west side of town. The matrices below show the cost of three vehicle types in dollar amount and current inventory of the vehicles in two colors, red and black, at both locations. So what they're saying is find the multiply the two vectors, the cost times the east location and the cost times the west location. Tell which location has the greater dollar value of red vehicles in their inventory, and find the difference in dollar values, and find the difference in these dollar values. Find matrix C times E plus matrix C times W. Describe what each element in the matrix represents. Okay, here are the matrices, and so you can see the cost matrix is actually really a vector, and it's the cost of an economy car, $16,580, cost of a sedan, and the cost of a pickup, $22,450. And then the east location is broken down into red cars and black cars, or red vehicles and black vehicles. 4 red economies, 6 black pickups, and then the west location is broken up in a similar way. That you can see there are 5 black sedans. Okay, here is a basic review of adding matrices, right? You have two different matrices, A and B, and when you have to add them, you add the similar elements. Element A11 plus element B11, and that will give you the element for the addition. So here's a real live example, adding matrix A to matrix B. Element A11 is -3, element B11 is 4, -3 plus 4 is 1. Okay. Likewise with subtraction, instead of adding, you're subtracting -3 and 4 in the same position. So you do -3 and you subtract 4, and that's going to give you -7. Now let's take a look at multiplying matrices. For multiplying matrices, you really need to know the dimensions, which is the row. The dimension is the row times the columns, right? So for this one here, you have 1 row, so it's 1 by 3. For this one here, you have 3 rows and 2 columns, so it's 3 by 2. And so here you have it right here. And the way you can tell that you can multiply them is that the two when you put the matrices next to each other in this fashion, you see the way they're organized from left to right, then the two inner numbers are the same, right? And that's the only way you can multiply them. And then they show how do you multiply. So A times D, right? That's what we have right here, plus B times F, plus B times F, plus C times H is right here. And that'll give you this element here of the multiplied matrix. And then same thing, A times E, B times G, and C times I. Add those together. Now let's take a look at how that behaves for this matrix here, because we have to find A, we have to find C times E, and C times W. And it's the same exact matrix that was in that example of multiplying matrices. So we have to go, right, 16,580 times 4 plus 18,690 times 7 plus 22,440 times 5, and add those all up. And so let's see, it'll be 66,005. Oh no, that's not accurate. It's going to be 66,320 plus 130,830 plus 112,250, and that's going to all add up to 309,400. Boom. So we've got one element, 309,400. And then we do the same thing, 16,580 times 12, 18,690 times 3, 22,450 times 6. And what do we get for that? Okay, Boom. We get one. I'm just trying to find these on my pad. 198.96 plus 56,070 plus 134,700, and that is, add those all up, and that's 389,730. 389,730. So that's what you get when you multiply these matrices together. Now remember, this is the number of red and this is the number of black, and this represents the total value of red vehicles and a total value of black vehicles. So on the inventory they have $309,400 of red vehicles, and the total value of black vehicles is $389,730. So then you do the same thing for C times W, and we end up with $292,980, the total value of red vehicles at the west side, $248,540 worth of black vehicles at the west side. Okay, make sure you understand how to multiply matrices. So here it is here, right? The cost, the dollar value of red vehicles at the east side, the dollar value of black vehicles at the east side, and so on and so forth for the west side. Alright, so it says, tell which location has the greater dollar value of red vehicles in their inventory and find the difference in these dollar values. Well, one of the things I want you to encourage you to do is when you're working with matrices, label the rows and the columns like I did here, because if you label them, you're going to be able to keep track of what's what, and you're going to know what it is. So I mean, so this question becomes so simple because you've labeled it. And so it says, hey, what's the who has a greater dollar value of red vehicles? Well, you take a look at the numbers. $309,400 is greater than $292,980. So obviously the east side has a greater dollar value. And then what's the difference? Well, you just, all you need to do is subtract them, and you get $16,420. Okay, and here it is. Here's the work here. Subtract the two, $16,420. That's the difference. Okay, the east location has the greater dollar value of red vehicles in the inventory. This is the answer I want to see. I want to see complete sentences, and I want to see your work too. Okay, find C times E plus C times W. So now we've found the total cost for each location. Now we need to add that together. Describe what each element of the matrix represents. So let's take a look at that. And review again, right? We add each element. And so what that works out to be is that when you add $309,400 to $292,980, you get $602,380. You add this element, CWB, or A12 to this element here, and you get $638,270. And what do these represent? Well, again, this is the red and this is the black, but this is the total value. The dealer has $602,380 worth of red vehicles and $638,270 worth of black vehicles in its inventory when vehicles from both locations are combined. Okay, I hope you found this helpful.